The development process for a Formula One car obviously starts at a conceptual stage, sometimes on Adrian's drawing board, sometimes on the different designers within the aero group, because obviously the aerodynamics are the predominant performance factor on the car. Concepts will be created and then will either run within CFD or within the tunnel, and then from there the results will be analysed and decided whether they are to make it through to full-scale production onto the car.
For an entire car, we usually start development for next year's car around about August, September time. So it's pretty much a 5-month window to develop a new Formula One car for a new season. Actually for 2014 that's a bit different because there are some quite big rule changes. So we've started work a little bit earlier. But typically it would be a 5-month window to develop a new car. From the first race to the last race in the season, in the Formula One season, we did getting on for 30,000 design changes to the car. So on average, that's about 1,000 design changes per week going through the design office.
We have an awful lot of rigs that we will simulate race situations and sometimes triple or quadruple the mileage that a component would see through a test cycle. So the sign off on any safety critical component is very, very vigilant. And of course from a reliability point of view as well, it's extremely important to test as many components as we can before signing them off to go onto a race car.
It's about deciding out of all the projects and all the things we want to change, what's going to give us the biggest bang for the buck, what's going to add the best performance to the car for the time and the resource required. The development race never stops. The composite is, for us, it's carbon fibre, but a composite can be a collection of any materials.
So if you take concrete, for example, concrete is cement with stones in it. You don't get the properties of concrete from stones, you don't get the properties of concrete from cement. You bring the two together and there you have a composite.
Carbon fibre within Formula One is something that's been around for probably the last approaching 30 years.
Composite bodywork's quite a complex and labour-intensive process, but it's a process we're prepared to go to make bodywork for the car. It starts off life in the technical office where the designers prepare designs, choose the shape of the bodywork they want. We have to manufacture patterns that we do on some of our larger machines here, and the patterns create almost a form, a shape, a copy of the shape that we want. And then we take that into our clean room where we lay up the layers of carbon fibre cloth. And that can be many layers, sometimes up to 100 layers. Once we've done that, we then seal all that together. We put it into a vacuum where we can suck all the air out and clamp the layers down. And then they're moved into our autoclaves, which could be considered a pressure cooker, where we cure the resin that's embedded in the carbon fibre cloth and put them under pressure at the same time to squeeze the layers together. Usually it's around about 180 degrees and up to about 7 atmospheres or 100 psi. terms of percentages, it's really difficult to say how much of an F1 car is made up of carbon, but actually all of bodywork. So every part of the car that you can see, the bodywork is carbon fibre.
Even the steering wheel is bespokely made to the driver's requirements, all out of composites, all the suspension, all the bodywork, the chassis, the survival cell that the driver sits within is all composite. The gearbox, now the majority of teams are using composite carbon fibre gearboxes, so it's a huge impact that it's had on the sport. The cars would probably look dramatically different if it hadn't been introduced.
We have over 20 large NC milling machines and mill turns, so quite complex programmable machines that are all there to machine pretty much every part of the car we could manufacture in-house if we wanted to.
The machine shop is part of the engine house of Red Bull Racing, and we're machining not only metallics, we're machining carbon composites as well.
One of the jobs of the machine shop is to constantly improve the way they machine parts and machine weight out of the metal. But really it's also about how quickly we can machine parts, because we need to get parts to the track to get there in time for the race. So machining parts quickly, but then additionally with the best precision and quality that we can, because we need parts to be reliable on track to help us win races.
Well, there's always been a balance between obviously the sophistication of the machines, but they're only as good as the numbers that you put into them. So the operators are still critical.
First equipment is men. We need lots of men because it's handmade. We need autoclaves, 5-axis machines, freezers, hand tools, lots and lots of different equipment.
You've only got to look at some of the work they're producing, and it's they're pieces of art, whether it's a wheel nut or the machining of a chassis mould. It's phenomenal the work that they're able to produce. But the paint process of the car is something that's critical, because one, it's got to look right, but it's a performance element as well. So obviously weight is a critical factor, so you don't want loads of filler and lacquer and build up of paint on the car. And of course you also need an extremely smooth finish and surface finish. So it's a very technical area that's often overlooked in terms of what it actually does contribute, because not only is it the aesthetics and the look and the feel of the car, it genuinely does contribute to performance as well.
Weight is our biggest challenge, so we're constantly trying to make the car lighter and lighter. It can sometimes be the case that we're machining parts up to the week of the event, where we then need to get those parts out to the track as quickly as we can. And that is the nature of this business, pushing change through the business as quickly as we can, working right up to the last minute.
The first build tends to take about a week, as it's almost like the creation of a very, very sophisticated jigsaw puzzle that all the components have to be planned, and it all comes together within about a week.
We would consider the chassis tub, the part the driver sits in, as the big bracket, and everything else bolts onto that. So we make 5 chassis, 2 race cars, 1 for each driver. We have a spare that goes to every race in a state of disassembly, which is an FIA regulation. And then we have 2 test cars. And at any point, those test car chassis can be in the factory having new updates added to them. We use a variety of machines to inspect with, from X-ray to NDT or non-destructive testing, where we can ultrasound a component or X-ray a component without actually having to break it to prove it's strong enough. We use CMMs or coordinate measuring machines, which are a computer-controlled, incredibly precise measuring machine, and even handheld machines that use a measuring device by laser. So I can walk around a car and probe the car with a Leica machine and establish its size and how well it's been put together without even having to touch it with a machine tool. So we use quite a wide variety of inspection equipment, again, really to 100% inspect everything.
The inspection department do a phenomenal job because they have a huge throughput of components. Almost 6,500 components are on any single car, and they're constantly evolving and changing, and all of those components have to be inspected, have to be signed off. So you know, the guys and girls here do an unbelievable job in the throughput, you know, of components that are measured to microns to ensure that their fit is exactly as per the drawing.
If you look at the areas within this company, and I dare say within our competitors too, each and every part of it is a necessary and vital step to realising the car or 2 cars put on the grid for each and every race. If we took any one of those departments out, then we wouldn't get the cars to the grid. So each and every step we follow has to be there, and each and every stage is therefore vital, and that's how we put the car together.